Okay, the back side of your notes is domain and range of quadratic equations. First, we have the equation here, f of x is equal to x squared plus 1. Note that whenever you see f of x, that means y equals. So, y equals x squared plus 1. You want to press y equals on your calculator, and then you want to press graph so you can see a picture. So let's do that. Press y equals. You're going to put in x squared plus 1. Then you're going to press graph. I want you to note something about this equation. We have it here where the y-intercept is at 0, 1. Second graph, I can see that. It doesn't appear to have any x-intercepts. So this does have no solutions. So that's just a side issue. But I want you to also note, what is the domain and range? This one right here, that represents our y-intercept. So right away, since I know the graph looks like this, and it goes through this 0, 1, my range is y is greater than or equal to 1. My domain, it goes on and on forever. It's all real numbers. It never stops. All right, let's look at the next one. Before I even graph it, I know this is my y-intercept. Let's see what the graph looks like though. So we're going to put in 2x squared minus 12x plus 13. Press graph. Now, this intercepts up here, but that's not my vertex. My vertex is down here. Remember on the other one, this was the vertex and the y-intercept. That's why we use that, because this was also the vertex, as well as the y-intercept. In this case, the y-intercept is 13, but it is not the range. All right, we have to look at the vertex. So where's the vertex? We see it here. If you press trace, you see that's your y-intercept. Our vertex is down here, and it's a minimum. I know it looks like it is about a -5, but let's test it. We're going to press second trace, 3 for minimum. Left bound, we're going to be to the left of that point. Right bound, we move to the right of the vertex. And then we press enter. The vertex is at 3, -5. So this value right here is going to be our range value. So it's going to be, since it's a minimum, is y is greater than a -5. The x is all real numbers. Right? Now let's look at problem number 2. Here, this is in the vertex form, where this is y equals a times x minus h squared plus k. Here, I don't know if you noticed or you remember from your notes, this is our h, this is our k. So that represents our vertex. And even if you don't remember that, you can put this in your calculator and see. Our vertex is at a -2, 3. I know that from looking at the equation. However, you can just simply put it in your calculator. Y equals a negative open parentheses x plus 2 squared plus 3. Put that in your calculator, and you want to press graph. Notice that it is a hill, so that means that is a maximum value. So since it's a maximum, the range is going to be less than. So let's find that maximum value. Second trace for left bound, I got to move to the left. That says left bound. So press enter. Move to the right of the hill. Press enter. Guess, press enter. That is at -2, 3, which is that answer. It's a maximum. So it's going to be y less than or equal to whatever the number is. So in this case, y less than or equal to 3 is our range. Our domain is all real numbers. Right. Okay, last one. F of x is the same as saying y equals. Our domain is all real numbers. The range is going to be based on this value. So let's put it in. 4 minus x squared graph. Notice the vertex and the y-intercept are the exact same here. You can see it. Press trace. That's at 0, -4. So in this case, this point was the vertex is at 0, -4. The range is going to be y is less than or equal to a -4 because they're the same. It's just like this one. These two are alike. These two, you have to look at the vertex is different from the y-intercept. All right. One more where we define the domain. We say the domain is x greater than 2. It says if the domain, what is the range of this if the domain is all real numbers greater than 2? So we're going to put this in a calculator. And we're going to put in -2 parentheses x minus 3 squared minus 6. Graph it so you know what it looks like. This is what my graph looks like. There are no x-intercepts, so there are no solutions. However, we're not talking about x-intercepts, we're talking about domain and range. So we want to go to the table, and it wants for all values greater than 2. So all values greater than 2 is going to be 3. That's the bell. Let me pause this for a minute. So that means all values greater than x is 2. What is the domain? It's going to be -6, -8. Keep going on and on and on. So anything greater than 2 right here, what would the range values be? So you see that the range values, what they are. So you can go to the table and see it better. It's -6. So the y values will be less than -6 for all range greater than 2. Y is less than a -6 or equal to, less than or equal to a -6. All right. In a table, it says this shows sum of the ordered pairs that belong. It says sum of the ordered pairs. So we can use stat calc 5 to find the equation and determine the range. So go ahead and do that with your calculator right now. All right, if you go to stat and press 1 for edit, and you put your L1 and L2 values. This is your L1, it's your L2. Once you get them in there, you press stat, go to calc, and press 5. We're going to go all the way down. I'm going to store my equation, alpha trace, enter, calculate. So this is my equation. We can write that down. Y equals 1x squared minus 6x plus 1. And since it's stored here, I can go second graph and I can see my values. However, just press graph to see what the graph looks like. And it's a graph that has a minimum point, so all the y value is going to be greater than whatever the vertex is. That's my y-intercept. Second trace, minimum, left bound, enter. Go to the right side of that point, press enter. The point is 3, -8, which is this point here. So my range is going to be everything greater than a -8 for this graph. And I just want you to note that I know this is a vertex because this is where the graph changes. When they're in consecutive order, I can see where the vertex is located. The vertex is at 3, -8, right? The real world problems seem really straightforward. They're like your rocket problems. So if you need any help, see a teacher for those, and you should do very fine on domain and range of quadratics.